Hello, I'm Dr. Mike Jones and I'm the Managing Director of Impact Minerals Limited. And we're working together with the Mineral Recovery Research Centre at Edith Cowan University underneath a CRC-P project for the sustainable production of high purity alumina integrating membrane technology. And for those of you who don't know, the Research Centre is a world-class research centre in membrane technology, and we're implementing it into our patented flow sheet for the production of HPA. HPA is a little known but widely used mineral in a number of emerging technologies and new industries. In particular, we can single out the semiconductor industry and lithium-ion batteries, in particular for storage. We can see that HPA is an important mineral. It's on the Australian Critical Minerals list, and it is important both nationally and internationally for those two industries alone. We've been working with the centre now for 18 months. We're halfway through our 3-year project, and we've made some incredible breakthroughs in the production, not just of HPA, but also of byproducts, in particular sulphate of potash. So potash is a fertiliser, it's a high value product, and we produce that as a byproduct from our HPA process. And in particular, we've seen some excellent results from the membrane technology in that byproduct circuit, and we're looking forward to seeing further developments in the back end to produce HPA as the project goes forward.
The Lake Hope project leverages a unique geological phenomenon, West Australia's vast distribution of ephemeral salt lakes. While individually small for bulk commodities, their scale and accessibility are perfect for high purity materials. These are naturally acidic and benign environments, meaning we operate with minimal impact on biodiversity. Our focus is alunite, a nature-made combination of salt of potassium sulphate and aluminium hydroxide, which is the precursor to alumina and ultimately high purity alumina, or HPA. Over millennia, these lakes have acted as mineral concentrators. Nature has done the heavy lifting, delivering a feedstock that is already finely grained and highly reactive, which eliminates the need for energy-intensive drilling, blasting, or grinding found in traditional mining. This unique mineralogy allows us to bypass high-energy thermal evaporation or massive evaporation ponds. By integrating ECU's advanced membrane technology, we can purify SOP and recover processed water with a fraction of the energy used in conventional methods. We aren't just mining, we're performing precision chemical separation. By aligning the unique geochemistry of Lake Hope resource with innovative membrane technology, we're delivering high purity materials the world needs for a net zero future with the smallest possible environmental footprint.
The Lake Hope project is unique, with one ore body set to deliver 2 highly valuable products into growing end markets through a patented and industry-disruptive low-carbon emission process. With demand estimated to grow by 17% annually, and with an expected supply deficit of 78,000 tonnes by 2030, the fundamentals for the high-purity alumina market remain strong. In computing, HPA is essential for use in semiconductor wafer manufacture, chemical mechanical planarization slurries, and thermal interface materials used in AI chips. For light-emitting diodes, it forms the sapphire substrate, driving energy-efficient lighting and replaces outdated incandescent technology. And in lithium-ion batteries, HPA ceramic-coated separators improve both performance and safety for electric vehicles and grid-scale energy storage. Sulphate of potash is a co-product of the Lake Hope process flowsheet, delivering a premium fertiliser essential for high-value crops like fruits, nuts, vegetables, tea and canola, particularly across Australia and Southeast Asia, where soils and consumers demand a chloride-free source of sulphur and potassium. Global SOP market sales are between $4 and $6 billion annually, with demand growing between 5 and 7%. The team is proud to work with the CRC partners to develop and deliver impactful products for the future.
So what's the role of CPC engineering within the CRC-P? We are the engineering designers, and my name is Eugenia Figan. I'm the process manager. I have a team heavily busy with the process design as well as flowsheet development. And currently we are focusing on the production of the sulphate of potash, as well as the main part of the process, which is the high purity alumina. And we're looking into addressing also the effluents and recovering water and we are trying to use membranes throughout the process to both expedite some of the recovery of those, but also to reduce costs. We are very excited with how it's coming together, and once that's finalized, we're going to progress into a definitive feasibility study to then finalize the costs, and Impact Minerals can use all of that information to build the final plant.
In order to have a successful mineral processing projects, there are two important indicators: A, sustainability, B, viability. So these two parameters need to work together to deliver a high quality project which is sustainable. Membrane technology has the ability to support both viability and sustainability of the projects. It can help to reduce water and carbon footprint. It can help to improve the purity of the product. It can also help to recycle and use reagent into the process. In our center, Mineral Recovery Research Center, we have developed direct mineral extraction technology, and that it's a platform technology that can help a broad range of mining and mineral processing related projects. In HPA project that we have as a part of our CRCP project with our industry partners, Impact Minerals and CPC Engineering, we are trying to integrate membrane technology at different parts of the flow sheet, from the water recovery and recycling into product purification, into acid recovery, into water treatment and other aspects of the project. So we have received $2.8 million from federal government as a part of our CRCP project. The aim is to help supporting the flow sheet by integrating membrane technology. Membrane technology is going to help from the front end of the flow sheet in sediment washing, recycling of water, and helping managing the wastewater streams, towards the midstream processing aspects of the project, in KOH leaching, acid leaching, and also membrane helps in the SOP production line. Membrane can support in improving the quality of the crystals produced from SOP line. It helps purifying the HPA product. It also helps recovering the spent acids.
So far, membranes showed promising results in HPA production. For the next steps, we are going to use membranes for reagent recovery from different stages. This can reduce the chemical consumption in overall process. Membrane technologies can make HPA production modular with minimized water footprint and producing high purity products. We use membrane technology to recover water from the effluent that is generated in different stages of HPA production. Membranes showed promising results with removing up to 99% of suspended solids and colloidal particles from the effluent. We can also tune and adjust the purity of the recovered water with membrane technology. Another application of membrane technology in sustainable high purity alumina production is in the SOP crystallization stage. We use membrane technology to recover water from the SOP brine, and we can remove up to 20% of the water of this highly concentrated brine. This provides the opportunity for lower workload on the crystallization stage. For the crystallization of SOP, we use membrane crystallization technology. It's a modular technology that can recover high purity SOP crystals. Results showed 94% of purity of the crystals only in one cycle. We also can recover high purity water with electrical conductivity below than 10 microsiemens per centimeter. This highly pure water can be reused for washing purposes in different stages of HPA production.
By recovering waste thermal energy from different process stages for membrane crystallization, we can minimize energy consumption, minimize carbon footprint, and maximize sustainability.
Risk assessment is an essential aspect of workplace safety here at ECU. For CRCP project, we treat this as the top priority.
So within 5 years, we do hope to be in at least small-scale production now for high-purity alumina and also potash. We're going to build on the pilot plant that will be the outcome of our CRCP project and scale up to our demonstration plant. And at that stage, we believe that we'll be able to demonstrate that a combination of our unique project at Lake Hope and the unique technology from Edith Cowan University will allow us to be one of, if not the lowest cost producers of high purity alumina globally. And that will be a magnificent entry into that marketplace.